All right. Hi, everyone. Thank you for coming to the last Theory of Competitive Fairness seminar of the semester. Today, our speaker is going to be Nicolas Mattei. He's a professor of computer science at Tulane University. He's also the co-director of the Tulane Center for Community Engaged AI in New Orleans. He's done a lot of research that has been at the intersection of AI, machine learning, data science, economics, decision making, even psychology, and like he's had like an interest in like a lot of different things, but especially in like social choice and fairness. He also just got an NSF Career Award like about less than a month ago, so congrats.
Thank you.
Yeah, and he's going to tell us today about his work on leveraging data and artificial intelligence for human-centered computational reasoning and choice. So, Nick, it's all you now.
All right, sounds good. Thanks, Jiva. Thanks for inviting me. Thanks for everybody coming to the last seminar of the semester. I hope everybody's finishing out okay and having all their fun stuff, grades turned in and everything else. I'm going to do a talk, a kind of general intro, and then we'll dive into some sort of more specific work. This is a little bit is adapted from more of a GA talk, so I apologize for the TFC crowd. There won't be that many equations, but there will be a few, which we'll get to. And I'll try to talk a little bit about all the different activities that I'm kind of involved in, and then really spend a lot of time focusing on a larger project that we've got going on in the recommender system space, which is in partnership with kiva.org, which is a microlending website. And I'll talk more about that as we get there. So in general, I'm going to talk about AI and machine learning because it's everywhere, and things are kind of crazy. We've got a recent book, which I'll mention here in a minute, on computing and technology ethics. And my work is predominantly, as Juba said, in social choice, preferences, multi-agent systems. And since I've moved to Tulane and really started working a lot more with our Center for Community Engaged AI, I've really tried to focus a lot more on sort of applied problems in these spaces. One, because there's a lot of need for those types of things, and two, I don't know, it's kind of fun, and my students really like it, so it's been something that I like to work on. Juve already did a pretty good introduction. I'm from Kentucky. I went to the University of Kentucky for lots of my work. I used to work for NASA and build satellites back in the day when I was an engineer still. I spent a fair amount of time in Australia working with Harris Aziz and Toby Walsh, a lot of things around social choice and reasoning with data. I spent a couple years at IBM Research in New York, and I moved to Tulane in 2019, which is a lot of fun. So I give a lot of GA talks now, and to be perfectly honest, like everybody just wants to talk about generative AI, predominantly because this is what's in the news. I'm not a GAI expert, but I have started to use it in lots of different places. I don't know about y'all, but sometimes it kind of feels like this comic to me, which is, every time I give a talk, there's a new AI thing that is not a thing that I thought was AI. I'm a pretty big tent AI guy. And it seems to be changing a lot. And when most folks want to talk about AI, they want to talk about Gen AI. To be perfectly honest, I've tried it, quite a bit. I try to get it to write my talks about ethics and AI. It doesn't really do a great job. I asked it to generate a picture of me giving a talk. It did okay. It got tall white guy down, which was pretty accurate. But I think we all are pretty much aware, these things have a lot of logic errors. They're kind of model-free zero-shot predictors, and they're kind of interesting. They have a lot of interesting use cases, but I don't know a lot of interesting theory really on the Gen AI space. So I'll mention a couple projects that is intersecting with this, but it won't be the focus of our talk. To me, more interesting is the fact is all the AI that we use every day, right? It's the things that we get recommended to buy on the internet. It's the things that we have to listen to or watch. It's the people that we date and the communications that we see. It's the places that we travel. It's the things that we eat. It's the things that we read, and it's the jobs that we apply to, right? So at the end of the day, one of the reasons I've kind of started looking at a lot of these recommender systems applications is because you almost don't have a interaction on the internet that's not mediated by some AI algorithm in the background, right? And that's really largely because the volume of things that you can interact with is larger than anybody is ever going to ever be able to encounter in their entire life. And I think this is a well-known problem in the recommender systems community, that we basically have infinite option sets, that we have unlimited supply of a lot of these goods, and it creates a lot of interesting problems and a lot of interesting opportunities, especially for ideas around fairness in artificial intelligence. And so one of the things that the reason that we sort of did this book, and one of the reasons that we really wanted to dive into some of these community engaged AI things, is that the same AI algorithm, the same algorithm. I'm not even need to use the word AI. This is AI friendly space. The same algorithm can get used in a lot of different places. And what's really different when people talk about ethical issues is really what's at stake. Like, what are we actually doing? It's not divorced from the application, right? So the same algorithm for facial recognition, right? Like misidentifies my wife as my mother-in-law on Facebook. It also identifies whether or not I went speeding through a school zone. And in some places, it identifies whether or not somebody committed a crime, right? And so each one of these has vastly different values at stake if things go wrong. And I think that's where a lot of these issues kind of come up. And my thinking on this, especially around working on the book, is really around taking a lot of stuff from like Sheila Jasanoff and some of the social technical systems studies that have gone on over the years. Is technology is not sort of technology and AI, and however you want to kind of ball that up, is not sort of a separate inanimate object that has values, right? It doesn't have agency. It's not a person. I'm not a big Gen AI or strong AI guy. I don't think it's going to be a person. And so if you talk to a lot of philosophers, they say, well, it can't be ethical, right? Because the ethics don't apply. They kind of weird. Technology creates affordances. It doesn't actually have ethics, right? This gets into a whole argument about agency. But what's more interesting is that these things are bound up together, right? They're the systems that we create, the algorithms that we produce, the ideas that we sort of put out there into the world, are inseparable from the things that we end up doing, right? They're bound up together in this inseparable way. They change our social setting, and our social setting encourages or changes the technologies that we then produce. And I think one of the most interesting ones, and this is an example stolen from Sheila Jasanoff, is this thing like the stoplight, right? So some people would argue, stoplight is not technology, it's not AI, it's not any of this stuff. And at the end of the day, it's just a colored light on a pole, right? It's this thing that like they stuck at intersections. But if you go back to the early 1900s when the stoplight was first being invented, it did all of these weird things, right? So first off, it's an automated switching device, and so even early ones had some sensors in it, so it was sensing and reacting to its environment, which meets the definition of an AI system according to NIST. It's doesn't really do anything on its own, right? A red light doesn't mean anything. It's given power, given valence by the social structures around it, that we all choose to drive on one side of the road, that we stop when it's red, that the police can enforce it, right? At the end of the day, if it was just a light that changed in reaction to its environment, that doesn't do anything. It's the systems that we create around it. And I think even more interestingly, when stoplights first came out, there was a lot of arguments about how they were eliminating jobs because people used to direct traffic at busy intersections, and now those people no longer had jobs. So the AI traffic light was taking away jobs for as early as 1900, 1920, 1930. People in the early 1915s blamed it for creating alienation because people didn't have to wave to each other at intersections anymore. So because they were being told what to do by a machine, it increased road rage, supposedly. There's a lot of articles in the New York Times, for example, about this, about technology making us impersonal and disconnected from each other. And so, which sounds very familiar to some of us. And the last one, which I think is where it really goes off the rails, is the first traffic light that was installed in 1869 actually exploded and killed its operator. And so it's probably one of the earliest examples of an AI system killing its overseer in order to take control of intersections in New York. I give this history lesson not so much to make you appreciate stoplights in all their glory, but because a lot of these sort of technological concerns that come up, especially around AI right now, are older and deeper than I think we think they are, and these are perennial concerns in the way that these systems work. So what do we do? Well, we wrote a book about some of this stuff, and it's not just computer scientists. I think the highlight of this book was we had different reviews when it was going through. We had some people complaining it wasn't technical enough, and that ethics should only be written about by philosophers, and we had some folks complaining it was too technical, and that basically that we need more computer science, right? So we somehow managed to make no one happy, which means I think that we covered the space that we wanted to cover fairly well. And so in general, it's written with a bunch of awesome co-authors, Mandy, Judy, Sarah Jo, and Corey, who all really shaped a lot of what this book is. And it's designed as an undergraduate textbook for thinking about computing and technology and society at a very broad sense. We've got chapters on ethical frameworks, managing knowledge, which is really a fancy way to say big data, technology and society, professional ethics, things like that. The hook is really that we use a lot of science fiction to bring people in and to provide the case studies for this. And it's a really nice book that I think can be taught at a technical or non-technical level. I use several sections of it, both in my data science and my AI course here at Tulane. And I know Mandy and Judy both use it for more technical courses as well. And Mandy uses it for a less technical course, which is about just AI and ethics very broadly at University of Illinois Chicago. It's a lot of chapters, which are super nice. We have a lot of extra information. We have story guides that help you teach them. We have suggested module insertions for data science courses, AI courses, and machine learning courses. So if you are teaching that kind of class and you need some resources, please do check it out and consider it. The hardback's a little pricey, but the Kindle version's like 20 bucks. So you can use it in your classes without a lot of things. And I'm happy to talk more about that later on if folks want to do it. So one of the reasons that you think about these things, and so there's these sort of broad technical challenge, broad sociological challenges around AI and sort of what that environment is. And a lot of this, I guess, in the media now is, what can go wrong, right? So folks are being arrested. This is an example from here in Louisiana of someone who was picked up on a misidentification, was held in jail for over a week due to an AI facial recognition match. There's several of these hiring tools that are out there that keep getting built and scrapped and built and scrapped. And then even more sort of concerning in some spaces are these mental health services using chat GPT responses in order to try to help people. So there's all these, you can pick up at any moment a lot of these applications of technology in spaces that we think of as being, consequential and, things that we shouldn't be doing probably so blithely at times. And so again, this is not new for those of us who have been, in this space for a while. This really dates back easily to the mid 2000s. And if you want to just talk about technophobia in general, and this goes back to the stoplights, as I mentioned before, but I think this really came to the fore sort of in the late 20-teens, talking about a lot of these predictive systems and a lot of these recommendation systems being used for protected areas like hiring, lending, policing and sentencing, and things like that. And so here at Tulane, we've got this Tulane Center for Community Engaged Artificial Intelligence. It's a cross-school, cross-disciplinary center. There's Aaron and myself from computer science. We've got sociologist Andrea Boyles. We've got economist Patrick Button, and we've got some folks from public health, which is Alessandra and Karen. And so really it's about trying to look at where AI is being used and trying to understand what are the issues and how can we sort of do some of those things better. So of course we have our giant graphic that tries to sort of talk about what these things are. I guess the central kind of idea is that we want to integrate ideas from human-centered design and control along with, transparency and these bias fairness metrics, and really bring those from the stakeholders, right? And I mean stakeholders very broadly, like the folks that are being affected by these systems, the folks that are using these systems, and the folks that are building these systems with applications in a lot of the different research areas that we have. And so I'm going to talk about a few other broad center things, and I'll talk very much in depth about some work that we're doing with Kiva here in a second. But a lot of the idea is, to really, and this comes out of a lot of the work that I did with the book and thinking about my research and what I want to do. And it really is about moving from, at least to me, moving from a very technocratic view of this technology, right? If you look at something like Google, you look at something like Microsoft, you look at something like a lot of the ways that these systems are built, they're built very, very far from the people that they affect, right? And they're built with an idea that we're very smart and we can think hard about fairness, we can think hard about big problems, and we can implement technical solutions to these problems. And I think that that's a fundamentally flawed design ideology. I think you need to really work with stakeholders and understand their problems in situ, and like really work to make sure that the things that we're doing are, one, the things that they want, and two, that we're building things in a way that give control to them, right? Like that expose as much of the control over these systems to the people that are either deploying them or the people that are affected by them. Because this sort of like technocratic solutionism, which would be the sort of fancy word for it, I'm just not a big fan of. I'm a little bit of a hippie at heart on occasion. So some of the things that we do, we've held several of these listening sessions and community engagement forums We've been working with local nonprofits on problems that they have in the city of New Orleans. One of the big things here, if anybody's familiar with the history of police surveillance and police issues in the city of New Orleans, it's a big issue. It turns out people are very concerned with it. The police are still operating under a consent decree from 2005. And so one of the things that folks are working on, and this is with Ion Surveillance, which is a local nonprofit, is trying to have these question answering systems that really pull from city council transcripts, using retrieval augmented generation kinds of methods, to try to understand what is going on in the city, because it turns out folks that use these systems want to understand what's going on, but they don't want to like read or watch multiple hours of community meetings and things like that. So one of the things that we're working on, and again, this I think really inspires some of these retrieval augmented generation type methods and things like that, really making sure that we summarize the contents of these things in fair and accurate ways. There's all kinds of fun problems that crop up here, right? Turns out the city council actually talks the most at city council meetings, and if you use sort of dry summary, off-the-shelf summary-based solutions, you're going to really err toward the city council responses, which maybe isn't what you want when you're talking about what are the cops doing, how is surveillance being used, things like that. Another place, again, this is a big data operation, and this is again a lot of these projects are in partnership with our Tulane Center for Public Service, which is really nice. So students at Tulane have to take a public service requirement, so this really helps us make these partnerships and really bridge these gaps to some of these community groups. Court Watch actually looks at criminal bond decisions all over the city. Turns out that all this data is available. It's just available in multiple different city databases and other databases that don't make a lot of sense and are very difficult to understand. Court Watch actually sends volunteers into every court session in the city of New Orleans and takes observations. And so basically they have a giant data integration problem. And so they want to, take these volunteer court observations, public records requests, court dockets, which are, by the way, PDFs that are uploaded to the city's website every day, in case you're wondering how court dockets are distributed. And you need to extract all this information. It's really kind of a data warehousing problem to some extent. But then you have to do all of that, build all that infrastructure before you can do any of the fun analytics that you maybe want to do on the other side. So we spend a lot of time with students, really building up these ways to interface with the data just to get at some of these questions that folks want to have, right? What is the average bond amount by race that's been happening? And so then we can sort of build on top of that and use more of our ideas of algorithms, counterfactual reasoning, some of these notions of fairness in the way that these decisions are made. But in order to get to that, we spent a lot of time, building data systems to help out with these things. That's what I mean by really getting into the community and understanding, what are the problems that they're having. We do a lot of work, especially as well with the city of New Orleans, looking at their open data catalogs and looking at ways that we can sort of build those things up. Been doing a lot of stuff. Again, this is sort of straight machine learning, data science fairness. Patrick Button, who's in our group, does a lot of work with age discrimination in hiring. So he's got a long history of doing these audit studies across a lot of different factors. And so one of the places that we're kind of really interested right now is in an audit study. You've probably seen some of these things where you send out the same resume to two employers and you change the name from a white sounding name to a black sounding name, or you change the age from someone who's younger to someone who's older, and you hold everything else constant. And so we think that there's a lot of interesting work to be done here, and there's a lot of work already sort of in the fairness community about ways that you can improve algorithmic auditing using ideas from the audit studies community, and also how can we use ideas from computer science to really look at the ways in which these audit studies are done, because they're very, very labor intensive. Maybe we can help do those in different ways. And so what's the relationship between the existing literature in economics on audit studies and sort of the things that we're sort of working on in computer science? And this is getting going. We don't have a ton of stuff to really report on this one yet, but we sort of went through and took a lot of information from the literature and look at how you can do certain things with callback rates, and look at are these things going to be biased toward older, younger workers. And so we're looking at sort of lifting some of those lessons into larger messages, or larger lessons learned as we go. And a lot of other stuff that we have a lot of observational data, especially with public health, looking at how do we want to understand what are confounders, both in, let's say, suicidal ideation online, or the way that folks talk about school choice. New Orleans is a particularly weird place for school choice. It's fully fully um, it's fully voucher based. It's fully choice based. So students can actually go anywhere in the city. And so you have a lot of interesting interactions with that and these online review sites and how students do select schools. So that's all kind of center stuff. I'm happy to talk a lot more about that after the meeting or something like that. If people are interested. So it's been a lot of fun. So diving into something maybe a bit more technical that folks here maybe are a bit more interested in is looking at this problem applied to Kiva microsystems. And this is a NSF intelligent information systems project that's funded with Robin Burke and Amy Voida, both from the University of Colorado at Boulder, and Pradeep, who is the head of data science at Kiva. So Kiva is actually a co-PI on this grant. We've got a number of papers. I'll touch on a few of these, which are kind of fun. One was at FACT last year as well. So what is Kiva? Just to make sure that we're all sort of situated where we want to be. And so Kiva is a crowdfunding platform for microloans. It has lent about $2 billion over the last 15 or 20 years to folks in many countries, 77 total countries, about 2.1 million lenders. And it's at the end of the day, it's a recommendation system, right? And so what I mean by that is when users log in, what they're going to see is they see loans that are recommended for them, and then various carousels that have ordered loans within these, right? And there's a lot of interesting dynamics that happen in this market because loans only stay on the site for 30 days. The ways that folks write about their loans have a lot of impact on when they get funded. At the end of the day, there's a lot of the standard ideas that we talk about. If folks are coming to the marketplace and they're from let's say a South American country, and there's just not a lot of exposure of South American countries on the platform, there are other platforms that they may go to, right? So you've got questions about balance of capital distribution as it goes on. So you've got a lot of different concerns, a lot of different ethical concerns operating at many different levels of this organization, only one of which is the technical problem of, what is the recommendation engine supposed to be doing, and what are the priorities, or what are the fairness priorities that we should have for that recommendation system. So we've done a couple of different projects. I'm going to zoom through a few of these, and I'm happy to expound on them, a bit more. But I want to make sure we end somewhere remotely on time today. So this was at FACT last year, and this was really run by Jesse and Anas, who did almost all of the work along with Amy. And so this one was really focused on, again, getting in there and understanding what are the logics of the different stakeholders within this recommendation ecosystem, right? So, obviously we're all a lot more interested in fairness. How do we improve the fairness of recommender systems? How do we improve the fairness of these machine learning systems? And, what does that even really mean, right? And so if you zoom, at the organizational level, the structure of that organization impacts the fairness interventions that you can actually do, and what all you can even really think about. A lot of times, I guess in the technical work, it's very easy for us to get a little too focused on, how do we protect one group of stakeholders, or how do we make one key change that's going to provide fairness for everything? In reality, we have to understand that this is a contested value that exists all kinds of places, right? So, and we want to make sure that our research and the things that we do, the interventions that we take, have relevance for these ML practitioners. And so that's why having this deep partnership with Kiva, I think, is really interesting. And provides us a platform to do a lot of really good work. Even within the Kiva organization, there's different stakeholders, right? There are lenders, there's you or me or anybody who's not actually trying to get a loan on Kiva who comes to the website, right? And so you have the normal problems of, what am I going to see? What's the diversity of the loans that I'm offered? And what's that distribution look like? The lending partners, which is kind of this weird thing that they do, right? So there are actually nonprofits that work in a lot of these countries that are facilitating these loans. And those lending partners can work with various lenders, and they have certain requirements about capital risk, about the amount of exposure that they're getting off the website, and things like that. You have another level below that, which is the individual borrower. So if I live in a disadvantaged community and I'm out here trying to raise some money through one of these loans, I'm going to go to the platform that's going to give me the best opportunity, right? And so it might be the case, that I have concerns that are different from other people's, And we need to sort of figure out how to balance those things. Those could be group or individual fairness type questions. And lastly, we have organizational level concerns, right? So at the Kiva level, right, we want to make sure that we balance our risk portfolio, because if we go under, it's not really going to help anybody. And so I think, especially in recommender systems, it's really interesting to think about multi-stakeholder fairness, right? Multi-stakeholder and multi-definitional fairness. And this first part of the project was really going into Kiva, talking to a lot of these different stakeholders and understanding how they conceptualize the idea of fairness, because it's a little bit of a loaded term on occasion. And so what we talk about in the paper is this idea of fairness logics, right? So what are the principles or practices that we do that how we understand fairness in the way that we do our work? And so the questions are, what fairness logics are present in the entire Kiva ecosystem? Which stakeholders get prioritized by those definitions, and sort of what are the process of these? What are the applications of that? The second question is, are these logics complementary, or do they conflict with one another, right? So sometimes we kind of take it for granted that like fairness and optimization, or even multiple definitions of fairness, are incompatible, and a lot of times they are. But they're incompatible in the social choicey way, in the impossibility sense, not necessarily incompatible with the actual applied sense to, let's say, a particular question that we want to have. And in what ways can we do these design interventions to prioritize or help these different stakeholders? And so what do we do? Well, we kind of do a little taxonomic work in terms of talking about what are these different fairness logics, what comes out of these interviews. We actually interviewed 23 Kiva employees and users and some users of the system in order to kind of get at what they do. So this is a lot of Amy, Anas, and Jess's work in sitting down and spending multiple hours with these folks and doing these interviews. And then we kind of have some design recommendations that implement one or more of these fairness logics, and sort of how we can make interventions into the system that then inspires the technical work that we want to go do. So the second part of this talk is going to be that technical work. So I'll kind of get through the highlights of this and then tie it to our technical work. So the fairness logics, hopefully a lot of folks here kind of have seen a lot of these, right? We have this notion of utilitarianism or act utilitarianism, right? We want to do actions that maximize benefit, which we call consequence-based. We're really looking at what are the outcomes. There's ideas that we see in a lot of the interviews that are more contract-based. It could be deontological in some sense. Or sorry, those are the duty-based ones. Contract-based and more agreement-based, right? So this is like, we agreed to do something, so we want to make sure that there's this notion of sort of distributive justice in those. A lot of them are character-based. A lot of people articulate fairness through who deserves things, and why. And then obviously there's duty-based, right? And this is especially prevalent in a lot of these nonprofits and a lot of the interventions that you want to do with communities, because a lot of folks feel they have a duty to enact a duty to perform certain definitions of fairness. In the paper, we get a lot more into this. I'm going to kind of breeze through this, right? But there was some great quotes from a lot of the participants, right? And so you get things like this, right? You want to choose the loan that's the most impactful compared to all the other loans. And how do you do that? How do you evaluate that, right? And so there's a whole question of valuation of that, but there's also, you see this fairness logic in this definition of, what we want to do is we want to choose the most impactful, but you also see other versions of this. What is the least risky? What is the most, what is the best return on investment? There's all kinds of ways to measure this, but it's really about, what is the outcome of the loan decision going to be, or was the outcome of the intervention going to be? You also see things that are around character-based or virtue ethics type questions. Who's worthy of receiving a loan? What is the features that make a borrower more worthy than some others? And so you get kind of fun quotes, right? There are some lenders who don't like choosing because they don't believe in themselves as an arbiter of who deserves it, which is kind of weird, because what comes out in some of those interviews is they want the system to push them ones that are the most deserving, right? So they're almost like trying to push some of these concerns up into the system level, so that we have to, like, that Kiva now is, or any algorithmic intervention that we have might be the way to judge deservedness, which is kind of a weird concept, at least for me mentally. And so one of the other things is we look at the tensions among logics. This gets more into some of the papers that I think a lot of us are going to be familiar with, are like, where are the tensions between these, right? If you look at consequence-based definitions of fairness, there's benefit-based and cost-based, and a lot of times, people articulate definitions that are directly opposed to each other, right? And that's what these little exclamation points do in this graphic is, there are tensions between these where to satisfy one, we would almost have to sacrifice another. But it's been interesting to kind of get more of a map of this landscape and understand where these tensions exist. broadly speaking, the stakeholders, kind of actually do have different applications and different things that they say, right? There's a lot of folks in the organization, the organization really needs to kind of think about a lot more of these consequence-based ones. This relationship between the borrowing and the lending partner is really a lot of these contracts. You said you would do X, so we need to do Y. Then a lot of the character-based ones are really focused on the lender side, which is kind of interesting. But then these duties ones, right? What are the stated duties, missions, and goals? Like a lot of times these pop up across the spectrum of where folks want to do. And so obviously, like we can't fix all of these with the recommender system, but we can try to fix a few of them, right? And so that's what we're going to talk about next. This paper was at FACT last year. My new thing, I put QR codes for everything now because it seems like whenever I give a talk, people just have their phone. So I'm trying to convert all of my links on slides into QR codes, which seems to be the most effective way to like push it out there into the world. So yeah, anybody looking for those? And I'm not sure if we post the slides, but I'll have the slides on my website if folks want them later. All right, so I'm going to talk about one quick one, which is more of an applied data science project, and then I'll talk about more of our high-level philosophy about what we're trying to do in terms of recommendation interventions, which I think is going to have a little bit more meat for folks here. So one of the things that we did in partnership with a lot of folks that were at Kiva was look at fairness interventions to just direct fairness interventions to the recommender system. And can we do that in a way that makes sense? And so I'm going to flip through a couple of these slides quickly. The idea is that we're trying to do all kinds of fun stuff. Obviously, at least in this crew, we know there's a lot of tension between individual and group fairness. There's a lot of definitions here, which we've kind of already gone over. Generally speaking, what we want is that, especially for individual fairness, decisions of the system should be made independent of whatever protected attribute that we're interested in trying to protect. And I talked a lot about this multi-stakeholder, right? Which is that, especially in the Kiva situation, we have the providers, right? So it could be the authors of books and the users of a system. And you have this like really interesting tension across all these recommender systems of, personalizing for one set of users, but you have a separate side of the market that you want to try to be fair to. So I think really looking at this as an ecosystem type question or a multi-stakeholder question is really interesting. Brings in a lot of opportunities to do fun theory work. This is stuff that's in practice. Again, this is what the stakeholders could be. This is a recap of what we just did. This is kind of a much longer slide of what are all the different versions of fairness that people have articulated in these interviews. And going back to what actually got done, we did an experiment at Kiva back a couple of years ago. Was we've got these what's called a mixed hybrid recommender system, where we got multiple orderings over multiple carousels, right? And so folks can click through these and look at things that are farther down. There's a multi-armed bandit underneath of this that orders these whenever a user comes in, and that's really just designed toward user engagement. Their KPI for user engagement is add to basket. So it's not necessarily all the way to the loan decision. It's whether or not they've saved it to investigate later. And so what we want to try to do is, what are some small interventions we can do in order to try to make this system a little bit more fair? And again, this is a little bit more detail on what's going on underneath the hood. The big problem, at least with the one that we did on here, is Kiva loans only stay on the site for about 30 days, or they stay on the site for exactly 30 days unless they're funded ahead of time. And there's some weird user behavior stuff that you get with Kiva, where when loans are first put on the site, they receive a lot of attention. And right before loans expire, they receive a lot of attention. And so in the middle, you actually don't see a lot of fundraising activity for these loans. And that's kind of not great, because the longer they sit on the site, the less likely they are to be funded. And if something's not funded, then the user doesn't receive their fund, user doesn't get the borrower doesn't get the help that they need, and things like that. And so basically they added a row, which is spotlighted by Kiva, which is going to be using sort of a basic, a very, standard, mostly standard ML pipeline, predicting loans that are unlikely to be funded in the time window, right? Because it's looking at using past activity as a predictor of future performance. What are the loans that are the least likely to be funded within the window? And so adding a row to the layout system of the ones that are least likely to be funded, can we basically pump the funding rates of those loans? Can we try to get a little bit more distribution onto those, especially those ones in the middle? And so there's a lot of failure to fund, which is the predictor. This is a lot of the byproduct of that, using AutoML to try to get that through. Ran an A/B test with the add to basket rate. Again, really kind of weird stuff that happens when you're actually using real data. Turns out logged in users are much more likely to lend. And so you need to actually kind of diversify that across different things. This is getting into the nitty gritty of the way they measure their KPIs inside Kiva. This is part of a longer talk we had at KDD about 2 years ago. And basically what we end up doing at the end of the day is, putting this fairness slate in there with the loans that are unlikely to fund, and then trying to push those through. And what you end up getting is you actually see a very large increase in the probability, or an increase in loans that are being funded. So there's a little bit more throughput on the site. And we actually don't see a lot of sacrifice in terms of, if you want to call it, accuracy or engagement, because the layout bandit that picks where this row goes actually has this at about the 3rd position. And so it turns out that like this intervention, one, increased the throughput of loans, especially on ones that were likely to not be funded. It didn't significantly affect a lot of the interactions with the other slates. And it also, helped a lot of folks in the meantime. And so it was kind of interesting to sort of look at this exposure of neglected loans. So fairness is exposure. And ways that we can maybe modify the system in order to intervene this. And this is not a really deep technical result, but it was an interesting sort of data science project of, can we build something that like does actually change the fairness outcomes for these folks? And so one of the things that I think I've highlighted through this whole talk so far is that there's a lot of differences in how we define these things, the logic of what we're going to do for loans. And this gets to the question of, a lot of times in the research literature, what we're doing is we're looking for these dials, right? We're trying to trade off some notion of fairness. And a lot of times we're forced to trade this off with some other notion of accuracy. And we do our normal thing and we put these two things in tension and we say, okay, well, what is the right, what is the right definition of fairness? What is the right trade-off between these things? Can we sort of make this work? And so when Robin and I first started talking about this project, one of the things that we discussed is, well, there's a whole research area that's all designed to do trade-offs, right? And it's this notion of kind of social choice, right? So if we take ideas from econ and social choice, we build all this stuff, we get all of our fun areas of like computational social choice and algorithmic game theory. And so one of the things that we started working on is like, okay, well, what we want is we want to enable a system where we can have multiple fairness definitions that are intervening in the same system, right? So we don't want to build a recommender system that's got some loss function around a fairness intervention and combine that with something like NMF or some content-based filtering or whatever you're trying to do, and then just call that a day and sort of just like push these two things together. We want to try to think about what does a holistic system look like where we can bring interventions in and bring interventions out and use some of these other ideas from computational social choice is what I want to do because I do social choice stuff. So if we had more time, we talk about what preferences are, we talk about what constraints are. I do a lot of work with data, a lot of work with the ways that people express their preferences. Hopefully I don't need to justify that voting is a thing that people do to try to, bring together somewhat conflicting preferences. And so the question that everybody has at this point in the talk is like, well, how does this apply to recommender systems? And so I'm going to skip through a bunch of these things. One of the things that the way that we're going to look at this, right, is that recommendation opportunities, aka users arriving at the system, are resources, right? They're opportunities for fairness and they're opportunities to receive, to try to promote optimality or other things, right? And so one thing that we can do if we take like kind of a multi-agent view of the system is we say, okay, we have multiple competing fairness concerns. And what we want to do is we want to allocate these concerns, whatever they are, to these opportunities, right? To users that arrive. And so if you're a little bit into the recommender systems literature, this is kind of a re-ranking. I'm proposing a re-ranking type idea where we want to we have a set of interventions we could take to improve fairness. And we want to figure out how to met out these interventions as users arrive at the system. One way that this gets done a lot in practice is you do this as like a batch. You say, okay, well, all the users that might arrive tomorrow, we're going to go ahead and like pre-compute what we would do for them. And so you kind of lose a little bit of the dynamic aspect. And so we've got a couple of papers on this. But in general, we've got this thing that we call the scruff architecture, where when users arrive, fundamentally what we're trying to do is we're trying to allocate these things that we call fairness agents to that opportunity. We're going to have sort of a traditional recommender system. And here, I don't want you to think of recommender system as thing that does stuff. I want you to think of something like NMF, where we're really just using this as a proxy for the user's utility over the space of items, right? So this is the personalization thing. So when I say recommender system here, you can just think really complicated preference function over an infinite set of items, right? And so we're going to take the fairness concerns that are allocated, and we're going to combine it with the preference function of the user. And we're going to use some kind of choice mechanism, and that's a fancy word for voting rule, to try to intervene and sort of tailor the output recommendation in a way that is a combination of the interventions that we want to take and the personal preferences of the user. Okay, so I'm going to try to wrap up here in a couple of minutes. And so there's a lot of diagrams and then one cool graph, and then we'll call it a day. And so the basic idea here is, right, we're going to look at this as a social choice problem. We're going to have these notions that we're going to call fairness agents that are going to come from that work with the organization that we did. The fairness agents are going to basically be able to tell me how compatible they are for a particular user, right? So someone like Juba might lend more to one category or another. Juba might really be into cats. And so anything that has a cat associated with it, like he's really, really into lending. And so it might be the case that
Actually, I'm sorry, I'm like a bit more into dogs.
Okay, well,
my bad.
Fine. It might be a dog charity of some kind. And so then, we want to make sure that if we're going to show Juba if we're going to try to use him as an opportunity to promote fairness, we want to wait until maybe the dog charities are very under, they have a low exposure. And when Juba shows up, we go, oh, look, here's someone we can show a lot of dog charities to, right? And so these definitions of fairness are going to come from these these definitions of fairness are going to come from our work with the organization. And we're going to use that to define how we're going to match these things. And we're going to use an allocation mechanism. And we actually just use probabilistic social choice functions under the hood, because my whole thing is like, well, let's use standard mechanisms because then we know some of the properties that are going to come out of this. And so we're going to allocate them to these ranking opportunities, these re-ranking opportunities, which is a user arrival. And then we're going to basically take, okay, the user's going to show up. We're going to have some set of recommendations for that user. We're going to have these fairness agents that are going to have orderings over the list of elements. So this could be very simple, right? These are, people always ask me what these look like. So in Juba's case, we might have a fairness agent that says, dog charity should appear, one dog charity should appear at least in every list, right? And so that preference function from the dog charity is just going to be like, okay, if the list doesn't contain a dog charity, then I don't like it, right? So we're going to take all possible lists, and we can sort of formalize these in different ways. And I'll tell you what we've done because we've actually built this. But that's the idea, right? Is that these agents basically ball up, where you want the intervention to happen, what the actual intervention would be, and a way to measure whether or not that intervention was successful.
Can I actually ask you like a super quick question about this? So like you're defining fairness here at the level of like what everyone sees in the choices they have, like not on the level of the final outcome.
Right. Well, I'm gonna do both.
Okay. Right? Okay. Cool.
So this is the thing. I'm going to try to do both, and we'll see if you buy it. That's going to be the big question.
Sounds good.
And so there's a much more technical paper. This is at, I think it's under revision at Tours, so it should be pretty good. But it's got actual, equations and stuff where we define all of these things formally, which has been kind of fun. And I don't need this, right? This is what a voting rule is. This is why we want to use voting rules. And so what we're going to do, Brendan, or Juba, to your question, is we actually built all this when we tested it with data from Kiva and tested it with data from Movie Lens. And so what we want to look at is, what are the different allocation mechanisms that we could do? And so one is, each of these fairness agents also can look at sort of the allocation history, look at the choice history, right? Look at the recommendations that have been served and articulate how fair or unfair they think that history has been to them. And we bound this by a window, so you can basically say these dog charities can say, okay, well, over the last 100 recommendations that you've served, very few of them have been for dog charities, and so we feel like it's been unfair. And so then we can think about different, somewhat simple allocation mechanisms. One is we could just service, the fairness concern that thinks it's, been most unfair to. Since we have these compatibilities, right? What user is the most compatible? Static lottery doesn't really work. We also use probabilistic serial and another one that's weighted by the current unfairness. And I think the next steps for us are really to look at more complicated probabilistic social choice functions here that give us certain guarantees about exposure over time, which I think would be a really interesting way to think about this, because what you've got is this sort of online allocation problem where you want to look at the history. And so I think randomized choice functions are really the way to go here, because that would be kind of fun. And then for that integration phase that I talked about, we looked at 4 different voting rules, Borda, rescore, which is basically just like you use a weighted sum, and you could argue about what that weight should be. Eventually, we maybe want to hook that up and learn it dynamically. Straight up just Copeland, to see how that works, and trying that intervention. We did a couple of different definitions. Juba, this is to your question. So these agents can both articulate what they think a fair list would be, and we want them to be kind of single-minded in some sense, right? So again, in the case of the dog charities, the dog charity fairness agent might be, well, all the dog charities deserve to be ranked higher than every other thing, right? And so you basically just have these that could be very coarse definitions over, say, one attribute, but we want to check out, and we just want to see if we can instantiate this and get something to work kind of empirically. So one fun thing about working with Rexis people is like they're all for just like building stuff and like seeing if it works. And I'm over here trying to write proofs around it, and it's like, we need more assumptions. So what we built, and the results that I want to show you before we run out of time, really are, we use 3 different definitions. One is this notion of proportional representation, right? So we want to make sure that a proportion of the recommended items in the history are above some threshold. We look at something in terms of mean reciprocal rank, which is basically, we want to have one of these items within the top 5 of some set of lists. And then one is looking at exposure, right? And so we want to make sure that we've got, proportional exposure across some of these things. And so you can look at that as well. So what does this mean instantiated? Again, going back to what I was talking about in terms of data sets, turns out very large loans don't get funded very quickly on Kiva. So we sort of defined these agents. One is for the larger loans. One is for low performance sectors, right? So this would be things like textiles, water access, things like that. So certain sectors are protected, and also certain countries, right? So there's some countries that obviously receive fewer loans than others. We also do this for Movie Lens, where we just kind of instantiated these things, and we did some synthetic data as well. And these represent this is the proportional to the total data set that we have from Kiva. About 5% of loans are large, about 6% of loans are from sectors that are disadvantaged, and about 4% are from countries that are disadvantaged. And so what we did was we smashed all this together, we built a big system, and we kind of looked at what the trade-offs are. And it's kind of cool because what you get, and I know everyone in this room is gonna be like, of course you got a Pareto frontier, Nick. But I think it's kind of cool that we actually got a Pareto frontier. And that the choice of voting rule and the choice of allocation function actually give you different choices along that Pareto frontier. And so that we can in some cases, and I guess there's a larger sort of theoretical question around like, what are the shape of these functions? What are the shape of the interventions that maybe are compatible or maybe not compatible within this kind of system? But clearly you get some trade-offs here, which are kind of fun. And so this little guy here this is just the baseline, right? So this is using NMF to do recommendation and then looking at the data that we have from Kiva, and looking at, the triangles are the lottery, which is where we just take it weighted. We take just a random one. The circles are least fair. And you'll notice that the circles actually decrease in DCG. Normalized discounted cumulative gain is what we're going to use as our notion of optimality. So the least fair, like servicing the agent that says, hey, you've been the least fair to me, does lower your NDCG more than any of the other ones, especially down here. But we take the 1/2 norm of those fairness metrics and we see like we actually get a larger response with respect to satisfying all of those fairness conditions. And so depending on the allocation and the choice rule, you get a different pattern of responses on these. And so it's kind of neat to look at what are the trade-offs and like, why do these interventions sort of cause these? I think for me personally, the social choice guy in my heart died a little bit when we did this, because if you're looking very closely, what are you going to see? You're going to see that the weighted lottery, which just uses the normalized back time weight to create, to weight the agents, And then you take the rescore, which is basically where you weight those agents by that normalized back. That actually is up here in the top. So it turns out that using like a real voting rule doesn't get you quite the response that you maybe want. And in fact, you're maybe just better off having these definitions and using them dynamically. But I don't know, this is on one data set. Things are different in other places. We did this for Movie Lens with, again, these definitions that we sort of made up. Again, you get something that looks like a Pareto frontier. It's interesting to see that in some cases you can actually get a better NDCG while improving fairness. So I think a lot of times we talk about this trade-off between fairness and optimality, and I think that has a lot to do with the definitions that you use. And I think a lot of practical spaces, that tension may not bite quite as hard as we think it does. Clearly it does in some cases, but maybe not in all. You'll notice on the movie data set, these NDCGs are very low, so we need to get some more data. And we've got new data coming from Kiva to look at some of this. We have some synthetic data. The results are very somewhat similar, although Copeland does actually do better here. So in the synthetic data, we actually get a little bit better response from some of the traditional voting rules. And there's a bunch of other experiments that are all in the paper, which I'm going to skip through. And we're still working on this system. I think there's a lot of interesting questions going forward. Again, kind of recasting a lot of these recommender system problems into market-based problems, I think is an opportunity to talk about, to use tools from social choice, to use tools from algorithmic game theory, and to use tools from the theory of computation to talk about these systems. And I think recommender systems as a situated context are really interesting because you've got all kinds of stuff that is different from a lot of the things that we think about sort of traditionally in social choice and stuff. Is, you don't use up items necessarily. One of the big ones for me, which has really been tough to think about, is going back to one of the things I said early. We don't know all the agents and we don't know all the items up front. And any algorithm that needs to scan through all the items is a non-starter from the get-go because these item sets are huge, they're large, they're functionally infinite for the purposes of thinking about recommendation. And so that's a really interesting challenge, I think, a really interesting theoretical challenge is how do you work or how do you design mechanisms that work in these spaces where you really do have an infinite set of items that you're trying to allocate or think about. And again, I think we've been doing some other fun stuff related to this capacitated allocation problems. And that's pretty much it. I'm going to jump to my last slide. I had a whole other piece of a talk here, which I'm not going to go into. And again, this is really just looking at large scale AI systems. How do we do fun interventions related to fairness, and how do we build those systems in ways that are responsive to a lot of the stakeholders that we have? And so I'm going to stop there. Hopefully everybody had a good time. And see if we got any questions.
Well, thanks a lot for the great talk. I think we can spend like maybe 5 minutes taking questions right now. We're already at 1 p.m. So if people need to leave, you should feel free to go. And if you want to stick around for 5 minutes, yeah.
It wasn't that unhinged.
No, it was very reasonable.
It was a little less technical. I don't know. I looked at a couple of the older videos, and they seem to have a range, in terms of how deep dive we go.
I think you slightly oversold the craziness of your talk.
Not that crazy. Yeah, it's interesting. I don't know. So we've been working on some like more theory-based results for within this framework, right? So like, what does it mean? Because really what you want to do, I mean, the thing that I've been thinking about a lot recently is like, you don't want to necessarily, and I think, Juba, when you gave your talk on pipeline interventions, it reminded me of this. And I think this is where the interesting algorithmic problems are, because you've got users arriving, you might know a distribution over those users, but you might not. And you want to allocate these interventions in ways that are fair to the interventions themselves. So like you could sort of maybe factor away where the interventions come from, but like, let's say you're just looking at the re-ranker allocation problem.
Yeah.
Like, what are good ways to do that in these recommender system settings? Because the batch stuff, doing the batch stuff is like, it's silly, right? It's so what I mean by that is a lot of the papers in the space, you'll see what they do is they basically say, okay, here's all the users that could arrive. So let's pre-compute overnight the allocation that's fair according to EF1 or you know what I mean? Like they'll do stuff like this. Right. And so, but they'll do it as a batch and they'll do it overnight. But then the next day you have no guarantee that those people are going to show up at the system or anything like that, right? Yeah. So you really want to, I think, interact more with either sort of some of these machine learning with predictions folks, or these online algorithms ideas, right? Where, because you've got kind of a scheduling problem, you've got kind of an allocation problem, but it's like capacitated, because like, again, like the dog charity, like it might be the first 10 people all want dog charity promotion, that it matches really well to dog charities, but then you have to like move on, right? So I think you've got some interesting questions there. I don't have a ton of formal around that, but like that's some of the
Yeah, no,
stuff I've been thinking about recently.
but that makes sense. Like, there's a lot going on there. Kind of like the one shot setting here is kind of like interesting to study, but like there is a lot that's missing. So
Yeah,
like among some of the things they just mentioned, I think the time dimension like is interesting. Like you don't know who's going to show up when, and well, some people are going to show up several times. Some people are going to show up once. Some people are going to
yeah,
show up times for like once a month. Some people are going to show up every day. How do you deal with this? And like how do you incorporate
right.
information like over days instead of like resolving the problem every day and just completely forgetting what's going on?
Yeah.
But also, by the way, I just want to point out that Kezia actually has a question in the chat, and she's
Oh, here we go.
asking, given the vastness of the countries that you're considering, how are you going to ensure the definition of proofs and fairness is going to be meaningful for those different countries? And she's also asking if the profile of like attributes, including the sensitive attributes, is self-reported.
So that's a good question. There are various answers to that question. So I'll try to give you as many as I can. So Kiva's goal at a high level is to increase global financial inclusion, right? So their goal is to like basically make sure everyone who wants access to capital can get access to capital, which means that they operate in a lot of countries. They don't operate in every country. Now, why do they not operate in every country? Because they operate through these like loan providers. They operate through local charities in those countries that then help to find people that need the loans and things like that and work with those folks to get on the website. So it's really like a big charity that sits on top of a lot of little charities that happen in those individual countries. And so your last question, which is the easiest one, is the profile of attributes self-reported? The answer is yes, and those are largely coming from the loan provider or the borrowing. Sorry, I keep screwing up my words. The loan providers in those countries, and they work with the local populations to develop those loan applications. And so all of that's self-reported. Obviously, if we're going to go full game theory, like there's clearly weird dynamics that happen because of this, but at least at the level that we're looking at it, we sort of take it as a given. In terms of do ensure the definitions of groups fairness meaningful for those countries, those are coming to us from sort of the Kiva stakeholders. So in the experiment that we did, we just kind of picked some proportions just to see if we could do it. And then we took the sort of the countries with the lowest proportion of loans in sort of their data set to see if we could maybe bump those up into the rankings and look at their exposure metrics. I think at a deeper level, like moving forward, like we would need to work much more deeply with how do we define those things and how do we do that. And again, at the end of the day, there's some interventions that we're not going to be able to fix with the recommender system. And so I don't think at the level of the recommender system, we're going to be able to solve, everything to do with making sure that every country is represented in their portfolio in the same ways. But one thing we can do is ensure that at least exposure to, let's take a relatively simple one, exposure to loans from all of the countries are at least somewhat proportionate to the number of loan opportunities that exist in that country, right? So if we've got 1% of loans from Honduras, we want to make sure that the recommendations we make over a day, about 1% of the things that people see are loans from Honduras, right? So if you want to take this as opportunity, exposure opportunity, equality of exposure opportunity. And I fully agree, Ketsa, is that like, we're probably not gonna be able to fix that just by doing that, but that's the type of concern, at least operationally, that like Kiva would want to instantiate on their system. Now, does that drive all the way to impact for every country? I have my doubts, but it's the level of interventions that we have access to. But it's a good question.
Yeah, she's saying thank you in the chat.
Yeah, I got it. I think that's
yeah. I should probably call it a day because it's getting a bit late.
Yeah.
But yeah, kind of like want to thank you again, Nick, for the great talk. Thank you everyone for being here in the semester and staying until the last talk of the semester. And I hope to see everyone next semester. We'll try to resume probably around October, the usual time. But yeah.
Sounds good.
Yeah. Thanks everyone.
All right. Thanks everybody.